introduction.
So hey guys, I'm Shreesh Kulkarni. I'm currently a design engineer at Intel, and I have been involved in RISC-V development and contribution from across since my bachelor's. So for the past 2 3 years, I have been contributing to a lot of projects and development in the RISC-V space. I work with prominent names like David Harris, David Patterson, Hennessy. So I have also worked with Steve Hoover. So my journey with RISC-V started around 3 years ago. So currently, I'm working as a design engineer at Intel, and my main aim in life is to make sure the RISC-V adoption is universal, and each and every person has the tools and resources to build their own chip and succeed in their careers.
So, can you share a bit about your journey from starting, how you got into VLSI and got into Intel, and how you got into contributing to open source projects like RISC-V?
Yeah, that's a good question. So my journey with this entire semiconductor field is just like any other typical story. I joined my bachelor's in NIT Surathkal as as an engineer, and the first thing right, that everyone does is something called competitive programming. Like they learn
Yeah.
languages, Python, C, C++. Everyone starts falling in the rat race of doing data structures and algorithms. Learning new languages, competitive programming, etc. So that's how I started. My first year, I I was just like any other person who would in India who wants to become an engineer would do DSA, do competitive programming, etc. And after a year, I really thought this isn't what I really interested in. So I started digging deeper into the stack. So as you know, the tech stack is varies from the application layer to entirely to the chip, like how a chip works. So as I went deeper and deeper into the stack across the 4 years of my bachelor's, I started learning more and more about how how applications are made. So first you have the application, then you have something called your OS, operating system. And if you go deeper, you have something called microarchitecture. And if you go deeper, you have something called a transistor. And if you go deeper, you have something called physics. So the entire tech stack is built up on the foundation of semiconductors. So that's how the entire tech stack is built. So my journey has been really just going deeper into the stack. And currently, my passion currently lies in the field of microarchitecture and CPU design, and and that's where I discovered my true calling, or you can say, really it lies in the domain of CPU design, CPU architecture, and then when I started learning more about architecture, I came across RISC-V. So RISC-V, my journey with RISC-V started with. I'm really thankful for a specific person called Steve Hoover. I worked with him for a couple of projects in RISC-V, so that's where my entire RISC-V journey started. So when my research journey started, that's how I started, and I started getting deeper and deeper. I started learning more and more. I started applying. I started expanding my domains and skill sets, and eventually I worked with, which is I would call the highlight of my career. I worked with David Harris and David Patterson. They are the literal founders of the RISC-V architecture. So yeah, so my journey has been really going deeper into the application stack. And currently, after my bachelor's, after I graduated, I took up a job at Intel because we all know that Intel, AMD are the two big horses of CPU design. And I
Yeah.
mean, if yeah, so if you want to know if you want to know a place where you want to design CPU and learn about CPUs and learn about any architecture or any design, so it has to be Intel because Intel is the founding father of semiconductors industry. So I thought it is a really good opportunity, and I'm here at Intel, and I'm really liking my work here.
Okay. Yeah, that was very interesting. Even in my hackathon, also, I got to interact with Steve Hoover. And presently, I am also working on Maker Chip, DL Verilog, and like
Nice.
stuffs. So, for someone like a first year student, what how he can get into VLSI or RISC-V. So what is the best way to start contributing to open source projects?
Yeah. So again, I would my advice for any bachelor's, right, any first year student would be not to take it too quickly. First, understand and discover what exactly you want to target the VLSI domain. Because as you know, VLSI is very, very vast. There are multiple fields, multiple domains. So you really have to understand which domain you want to contribute to and which domain you think you're going to build your career on it. So let's say, for example, I thought so my domain in VLSI should be RTL design or microarchitecture. So I'm supposed to work towards that. So let's say if someone else wants to contribute to physical design or wants to actually contribute to the back end of how the chip works, floor planning, routing, etc. So that's how they should target. So my advice would be if you're a first year student, first try to understand how the industry works. First try to understand how the VLSI domain is exactly. What are all the
Yes.
different fields and what are the entire design flow. So if I want to design something, let it be anything. It can be a software, it can be a hardware, it can be anything. What are the different steps I should follow? Right? So if I want to design any chip, I have to understand what is all the steps. If you have to understand the whole design flow. You have to understand how do you code the design, how do you code the logic, how do you design it on the chip, how do you do floor planning, how do you do routing, how do you do the clocks. So how do you bring power to the chip? How do you optimize power to the chip? So entirely and finally, how do you send the chip to the fab for manufacturing? So once you discover the flow and once you read each and every aspect of the flow, you will eventually come to realize which domain you want to contribute to and which domain you are really interested in. And each domain, it might be physical design, might be manufacturing, it might be even architecture design, or it might be even software. Each and every domain has an open source company or open source contribution for it. So you don't have to worry whether open source is really dead or not in that domain. Each and every domain has an open source
Yes.
requirement, and if you really want to, if you're really interested, you can contribute in any domain. So that's
Right,
what would be my main
exactly.
advice.
I would like to add to this, like
Yeah,
how do students discover their domain? Like uh, I I have done Kunal Ghosar courses, so he told that we should do some VLSI awareness program, like 4 week, like 1 week program in which all domains of VLSI are covered. So
right.
in this way, we get to discover our domain. Like he have an ASCOM program in which he covers various domains of VLSI. So
Right.
would you like to add up like how do students find out their domain?
Yeah, again, that's a really I would say not really a challenge currently. If you compare 5 10 years ago, it was really hard to have any understanding. But currently, we have so many courses, as you mentioned, right? NASCOM program going on by Kunal. So if you keep out, if you keep your eye out, if you keep your eyes and ears out for all the opportunities like this, you really won't be able to miss anything. You really have the entire full package. So let's say I think Anushka has a really good community for RISC-V and VLSI. So let's say you join the community. She is posting every day about all the different programs, different opportunities. So you really can't miss on, won't be able to miss on anything if you keep your ears and eyes open to all
Right.
the different programs that are happening. So that would be my only advice here. Just keep your ears and eyes open.
So how did you build your skill set, especially like RTL design, architecture, and verification?
Yeah. So, what my philosophy is, skills can be either built in two ways, either by experience, uh, or towards by a mentor or to some any company. Let's say you join Intel and you have experience there, and you get to know how to design, or by self study. So I would advise almost, let's see, in my case, how I built my skills was always self study, because only you are the real judge on how the skills you're going to implement. So if you have any skills which you want to implement, it's entirely up to you which skill you want to target and which skill you want to study. So again, that's entirely up to how the flow works. So for me, in my case, I figured out that RTL design is what my interest in. So I just went to Google and just searched, right? What are RTL design? What languages are being used? Verilog, VHDL, system Verilog. So I'm up to the it's like a video game, right? Once you start a video game, you don't know anything, so you have to follow the tutorial. You have to explore the world, right? So that's how I would recommend everyone. So if you want to target a skill, first do the exploring part. Go to Google or go to anything. Just explore what are all the different languages, what are the different tools they are using, and what is the industry using, and what am I supposed to do with that. So that's how I built my skill set. I just started exploring each and everything, and eventually you'll come to a point where you think, yes, I have explored so much that I already know a lot about it. So exploring is the key here. So never stop exploring. Never stop your curiosity for learning. So once you have that curiosity, you will never fail.
Right, curiosity is really very important.
Right.
And so for us, so let us now come out that how. So for a student or engineer new to RISC-V, so what is the best first project to tackle? Like,
Right. So, so first let's understand what RISC-V is actually. So RISC-V is the instruction set architecture, right?
yes.
So you really have to understand how RISC-V going to help you in your project, right? So let's say I want to build a CPU. I have to understand how is RISC-V going to help. What are the advantages RISC-V has? So so you have to really understand what RISC-V is actually in the entire depths of it. So what extensions, what instructions, what software, what hardware does it support. So again, if the simplest advice I would give is to just design a circuit, right? A simple adder circuit, full adder circuit. You want to add two numbers, or you want to add two vectors, or you want to add 1 plus 2, 2 plus 3. Okay, I've designed a circuit for it in Verilog. Now, how will that get executed in a RISC-V processor? You have to understand RISC-V has some instructions. So each instruction gets mapped to a specific operation. So that's how you are supposed to think. So the first, let's say, the most important project which I would recommend everyone to get started is to design your own ALU, or ALU also stands for arithmetic logic unit. So if you want to design an ALU, first you have to learn how ALU designed, and once you design ALU, you can design other components of a CPU. So you have to understand how a CPU works. So CPU has memory and data, memory, and decode, fetch, etc. All the pipeline stages, right? So you can start. The most intriguing project which I have ever done is a single cycle processor. So you can build your single cycle processor in Verilog or any other language, and you can implement that using the RISC-V ISA. So there are a lot of resources online. You can check them out. I would recommend a book by David Harris. It's called Complete Architecture RISC-V Edition. So there they've really guided you how to build your own processor from scratch. So yeah, so my advice for the best project ever. So if you want to get started to RISC-V, the most important project is to know what RISC-V is. So you have to build a CPU. So a single cycle processor, a simple single cycle processor with just addition, subtraction, multiplication. That's it. You can design that in a couple of days, a couple of weeks, up to you. So there's a really interesting book by David Harris, Complete Architecture RISC-V Edition. You can refer that book, and they have really guided you how to design an entire CPU by scratch. So I would recommend you follow that book first, and you can go ahead and start your project journey.
Yeah. So how did you join some open source organizations like I've seen you have done a lot of open source contributions.
Correct.
So how did you get there?
Yeah. Again, I would like to reiterate to my original point. You have to keep your eyes and ears open. That is the most important thing. So that's what I did. I kept my eyes and ears open, and I started looking for opportunities. So I came across Steve Hoover's LinkedIn post up 3 to 4 years ago. He said that he wants some open source contributions for a new project called Warp 5. So I thought, okay, uh, this is something new to me. I can start. And I sent an email over to Steve Hoover and said that I want to work with him. And he replied saying that, sure, we can have a meeting and we can work. So that's how I started my open source journey. So so my work with Steve Hoover really opened a lot of areas to me. I met through Steve Hoover, I met a lot of folks in the RISC-V industry, open source industry. Eventually, I just started climbing up the ladder slowly, slowly, and I think RISC-V has, I think, almost every year it holds something called mentorship programs in the Linux Foundation website. Yeah, so you can apply for those, and there's also something called Google Summer of Code. So GSOC is entirely an open source platform, and you can apply for that. So it's all about keeping your eyes and ears open.
Right. Right. So let us now start with RISC-V. So where do you see RISC-V for in next 5 to 10 years? Like,
So yes, so that's a really unpredictable question because as of now, RISC-V is very, very early because it's not mature enough. I think RISC-V came around 10 years ago, so it's really not that mature, you could say. So that's so we don't really we can't really know exactly what RISC-V will be. So so what my vision I can say for RISC-V is for the next across the next 5 years. So the next 5 years, I believe RISC-V will penetrate the HPC market. So HPC stands for high performance computing. So currently, I also mentioned this in the IIT Madras when I recently went for the symposium there. I talked to Inco Semiconductor CEO, and I expressed my concern over that RISC-V still doesn't have a decent single instruction multiple data extension. It still does not have a fully implemented scalable matrix extension compared to ARM or compared to x86. So I asked him this question. So he agreed with me that RISC-V still does not have any any extension or any support for the HPC market. So all of these extensions can be only utilized in the embedded market or the low power market. So for the next 5 years, I really hope, and I'm in constant contact with RISC-V people, RISC-V Foundation, to develop a very strong and foundational SIMD extensions and compared to x86 and ARM, so that we can tackle the main market. Because we know the biggest market in the chip industry is the HPC market, data centers, AI, acceleration. I mean, everyone's talking about accelerators now. So data centers, client, CPU, laptops, desktops. So RISC-V still hasn't penetrated that market yet because it simply cannot. It cannot compete with x86 because it simply lacks the resources. It simply lacks the required extensions to compete with ARM or x86. So my vision for next 5 years, I hope it happens. RISC-V should really get a foundational platform for HPC market. So they should really have a lot of SIMD extensions, a lot of customer support, a lot of firmware support, a lot of platform collaborations. So that's what my vision is, and that's what I hope RISC-V for the next 5 years will. That's what will happen. We will eventually penetrate the HPC market, and we will eventually design chips which are competing with x86 or ARM.
right. So so India has been making significant strides in semiconductor design. So how do you see RISC-V contributing to India's ambition of becoming a global semiconductor hub?
That's a very good question. India is, as we know, India has a lot of talent. The talent pool of India is really big. So, and India is actually, if you go to the RISC-V website, India is actually a lead premium sponsor of RISC-V Foundation. So, IIT Madras also is a founding member of RISC-V Foundation. So, again, the main issue with India's thing is, again, we don't have the government support. So I really think that RISC-V can really bypass that because RISC-V, as you know, is an open standard ISA. So there are no restrictions to design anything compared to x86 or ARM. So that's where we can break free. And I think India's potential is really, really huge for RISC-V. Uh, I would assume that in the next coming years, eventually we would get a very low process node fab here. And I think the only drawback in RISC-V is we do not have any fabs. So our only fabs which we have are very old, mature nodes, so 45 nanometers, 30 nanometers. So, and as you know, currently each and almost every chip, almost every high performance, low power chip will require a low process node like TSMC 3 nanometers, so 18A or anything like that. So you really need a high performance low node, low process node. So India still does not have the capabilities to manufacture that. So if once in India tackles that issue, we would be the competitors. I would say the main competitors in the RISC-V space, and I think the Indian government is really pushing to do that. And we eventually will have a manufacturing site here which can manufacture high quality process nodes so that they can support our startups in RISC-V. So IIT Madras has a really good incubation center. We really have a lot of startups there. We have Incore Semiconductors, Chakra Innovations. We have yeah, there's a lot of Shakti team as well. So a lot of people are working on RISC-V. So if more and more people start working on RISC-V, more and more talent we use, and more projects we build, that's how our presence can increase in the across the entire world. So that's what I would say. India's potential is really big, and you can see that a lot of companies are coming to India to hire RISC-V engineers. So recently, IBM decided to design did come to India and make a RISC-V team for that power architecture for this the data centers. So again, India's talent pool is really big, and I think the startups we have at IT Madras or any other startup are really contributing a lot to this ecosystem. And I believe that we as Indians, we can really contribute a lot to the RISC-V ecosystem and make sure it flourishes and you know have a manufacturing fab in India, and we can really support and we can really be the main competitors in the RISC-V space.
Yes. So, how can Indian universities and engineering colleges play a bigger role in RISC-V ecosystem?
Yeah, okay, that's a very good question because, as we know, almost 90% of current Indian colleges do not know what RISC-V is. So
Right.
if you go to and this includes IITs as well. I mean, I'm not just discriminating. That's only the bottom colleges will not have access. This I mean, I'm from NIT, and I know that each and every college, almost 90% of colleges do not have this file still included in their courses. So if you go to IIT Bombay or IIT Madras or even NIT Kasirutkal, if you just attend a microprocessor CPU design class, they are still teaching you 8086, 8085, 8051. These CPUs were more than 100, I mean, not in 100, sorry, more than 50, 60 years ago. So why do we need to learn something which is 60 years old? And why should we ignore which is something really hot currently, which is RISC-V? So they are still teaching us 8086 processors. They're still teaching us MIPS. MIPS is a architecture which is entirely been stopped entirely. So there is no one is still adopting MIPS today. So
Right.
they're still teaching MIPS and still teaching 8086. So that is the main issue in this education system in India. So we have to tackle that. So we as people we have to tell our professors, or we can also contribute. As we contribute more and more, the more and more the professors and the education system can realize that we have to have some courses or we have to have talent towards the trending topics in the current industry. So Indian university really play a really key role. And again, my advice would be, or if there's any university which is top, which is here, my only advice is to be entirely focus your curriculums or your teaching methods, etc., to follow the current trend, right? So there's so much happening currently, and we do not have time to focus on something which has already happened 60 years ago. So we have to be
But
focused.
I would
Yeah.
like to add a point that 8051 is very basic. Someone who is not familiar to computer architecture, 8051 I think act as a bridging between basics to advanced. So I think that should be
Yes.
included, but in second year, in early third semester, I think that should be taught, and in higher semester they should have RISC-V.
Yeah,
Even
I mean,
I studied
I
from
really agree. I mean,
IPS.
I entirely agree with that point, right? Because it's totally fine to have your 8051 and 8086 courses, but do not make the not make the entire course as a highlight of that thing, right? You can
Right.
really have a few chapters, study about 8051. It's a really good basic fundamental learning, but do not go the entire course on that specific topic. Right? You have to move on, right? So you
Right.
can't have an entire semester focused on only 8051, right? So let's say the entire semester has around five six models, so 5 6 chapters. So all the chapters are focused on 8051, 8086. Is that really needed to go that deep into that and learn what each and every pin of the chip does? I don't think so. So just the
Right.
basics fundamentals is enough, and that can be completed in a couple of weeks or a couple of months even. So that's entirely fine. I mean, I agree with that point that basics are really important, right? But do not make basics the entire highlight of your skills, right? You have to adapt, and you can't just say that my entire semester was. Let's say someone in a job interview asks you, "Do you know RISC-V?" You can't say no, sir. I just had 2 courses in CPU design. All of them courses were centered only around 8086. That should not be the case. You're supposed to have 8086 knowledge as well as the current architecture, current trend knowledge, right? So I entirely agree with the point. You're supposed to have the basics, but do not just dwell on technology which is around 80 years old. You have to adapt slowly, and it's not a bad thing to have knowledge of both old and new architectures, but I would always suggest all universities to just brief about the 8086, just have a good understanding, just build that curiosity among students that 8086 was the first chip developed by Intel. So you have to build that curiosity. And once the curiosity is already built, you can slowly and eventually transition to new architectures. So that would be my advice.
Yeah, in our college they teach 8051 and MIPS, and in final year they give us 5 project.
Yeah, that's the issue, right? When I already reach final year, so at the first year, let's say you're learning 8086, so you have to wait 4 years to learn RISC-V. So in that 4 years, everyone else around you has already learned RISC, is already designing multiple CPUs around you. So you really feel left behind. So
Yeah.
that's the main issue which I feel is currently prevalent. So if you learn 8086, I don't mind. 8086 is not a complex chip. You can learn it in around 2 months. So once you learn it, move on to the next architecture, move on to the next chip,
Right.
move on to the next trend. So you have to be always adapt, always be updated.
So how can Indian engineers in traditional VLSI roles like ASIC, FPGA, RTL transition to open source RISC-V projects like open source like RISC-V carrier?
Correct. So that question is a really big good question because I'm also an Indian engineer and I'm also working in the ASIC, FPGA, whatever domains at Intel, and I'm also contributing to open source RISC-V repositories and the foundation. So the question is not about transitioning. The question should, well, I mean, the main issue here is about how do you actually implement your skills which you have learned in open source domain. So if you really want to transition to, let's say, I want to contribute to open source CPU design, it's really about understanding what open source organization works on which domain. So you have to really understand which organization is currently is working on this domain, is working on RTL design, is working on open source stuff. So open source is really easy. A lot of people complicate it, but it's just really easy. You just have to go to GitHub, just search for open source RISC-V organizations. So you'll get an entire list. So what I did actually when I was in my second or third year, I went to the GSOC page, Google Summer of Code website. You can go to the website now and just search the previous year's list of organizations, and you can go through each and every one of them, and you can actually filter out what all the RISC-V organizations there. So you have Redwood EDA, which is also doing the RISC-V open source, and also for GSOC. You have Chips Alliance. So all is there. You have Beagleboard. So it's again it's entirely up to my initial point, right? Keep your eyes and ears open. You just have to open source is really simple. Just go to GitHub, just talk to the maintainer, and say that I want to work on this, and I think I can improve your design. I think I can improve your CPU. I think I can make some changes to it. I think I can make it better. So you can just give your thoughts on that, and once to really connect with. And open source is really quick, right? Because the people there, I mean, if you approach an open source maintainer, repository maintainer, he'll reply to you almost instantly. So they are really supportive. The open source organization or the community is they are really supportive, and the RISC-V community is very established. And if you want to approach them, you can approach them, and they will guide you. So that's how, I mean, open source is really simple. So you just have to know what you want to work on and just search upon that. And once you search it, just talk to them. Just communication is key. You have to communicate with them and say that I can make this design better. I think there's some issue in this design. So once you start that process, you'll eventually be sailing through. And to actually I actually came I was also in your place. So who were watching this, right? I was also in your place, right? I did not know how to contribute to this fight. So after so much years, I talked to the people at Display Foundation, and I told them that a lot of people, a lot of juniors, a lot of enthusiasts are messaging me, asking me how do I contribute to this fight. I don't have a roadmap. So I introduced this problem to the RISC-V people, uh, to the entire community, and me and along with them, we came up with a repository. So you can just go to Google and just type RISC-V learn. So RISC-V learn is a repository which me and the RISC-V International created, and it is a really good repository. It tells you everything from scratch how to get started in RISC-V. It has crafted an entire roadmap for you. So we have done everything for you. So you just have to go to the repository and just start learning. So as I said, right, we have made it very easy for you. The RISC-V community has made it very easy for you to start contributing. So you can Google that right now. You can just go to RISC-V/learn, and you will come up with the GitHub repository. Yeah,
Yes.
and you can just start your journey with RISC-V.
Like I want to add up to that. Like there are RISC-V SIG groups also, right?
Correct.
And
Yes,
like you have to become a member and then you can
correct.
join their groups, and there they
Yes,
discuss that what projects they are working upon, and we can talk to them and start working with them, right?
correct. That's also right. Yeah. They
Like
also hold meetings almost every week, weekly, twice or thrice. Respected. They have a technical committee every week, and they hold meetings every day. So you can just join them. They're on Zoom. They are free to join. Anyone can
that
join them. So just join them
RISC-V,
and just yeah.
they launched their calendar also in which they have
Yes.
given when they have
Yeah.
meetings.
Correct.
So in our previous podcast also we talked to a RISC-V advocate. He told about all these things also.
Yes. Yes.
So in that video, I have shown that how you can join the RISC-V groups and start contributing to RISC-V. Is
Yes.
okay. So next question. So what unique advantage does RISC-V nature offers to Indian startups compared to architectures like x86?
Correct. So again, that's the main, let's say, tag of RISC-V. It is open standard, right? A lot of people think it's RISC-V is open source. Again, RISC-V is not open source; it's open standard. It's a big difference actually.
Right.
So open source is something which the source code. Let's say if you declare a project as open source, you have to release the source code to the public. But if you declare your, let's say, your project as open standard, people can use your project, but they cannot see what's inside. So that's exactly what open short and open source is. So RISC-V is an open standard ISA. So let's say if I want to design my CPU with RISC-V, if I say it's open source, I have to tell everything about it. If I say open standard, you can use it, but you cannot see what's inside. So that's how the RISC-V open standard is, and that's what I think it's key difference between x86 and ARM. So ARM and x86 are really closed systems, right? So they do not have, they really, whatever IPs they sell, they're a closed system, right? We have to pay for it, and there's a fee for it. So the main tag, which I think RISC-V can really have a very, very big advantage, is because it is open standard and open standard. So that's the main thing here. So if you're a startup and you want to design something, you just have to go to RISC-V and see which CPU you want to use, which CPU will meet your requirements, which product you want to target. Let's say if I want to target and I want to design an embedded controller, I will see which RISC-V extensions do I need. okay, a controller does basic let's say I want to design a DSP. So I would need math, something which does a lot of math. So floating points, so integers, multiplication. So you can find a CPU which does all this in GitHub. So you can just go to the GitHub repository of RISC-V and you can just ask them, I need a CPU which does all this. Can you give it to me? They'll give it to you. So and you can design a product on them. So it's very flexible compared to x86 or ARM. So RISC-V is very flexible. It's open standard. There's no such thing as intellectual property something going around here. So you have the flexibility and you also have the lot of resources to build your product on that. And if you see ARM or x86, they are really closed source projects. So you really don't have a much of flexibility there. So that's what the key thing is. RISC-V is really flexible and it also has a very vibrant community. So the community of ARM and x86 is really closed. There are only a specific set of people who you can approach. Uh, you know, people who are experts in x86 or ARM. You can approach them and ask them for help. But in RISC-V, it's entirely open. There are thousands of people who have worked on RISC-V, who know the ins and outs of RISC-V. So it's really flexibility is really big in RISC-V, and communities engagement is really good in RISC-V. So these two factors I think are really important, and these two factors I think will be the biggest advantage over other architectures.
Yeah, so I would like to add something like, so RISC-V ISA are publicly available under Creative Commons License 4.0 International License, right? So it is not actually open source.
Yes.
Yes. So next is the future of RISC-V startups in India. So where do you see RISC-V startups in India 5 years from now? So competing globally or carving out a niche domain in a specialized domains.
Yeah, so the RISC-V startups, right? The main issue with RISC-V startups is that they do not have a product or a market which they want to target. So the VLSI market is really difficult compared to software market. So let's say if you're a company want to build software, you can there is no restrictions or it's a really general purpose there. You can build any software that you want, and any market is can be contributed to that market to that software. So that's not the case with VLSI, right? You have to be entirely specific which market you want to target. So if you want to target a low power market, I have to design a product based on that. If you want to design a if you want to target the high performance market, I have to design a product or design my chip based on that requirement. So the RISC startups in India, they have to understand which market they want to target exactly. So currently, I think most of the RISC startups in India are from IIT Madras, and they currently are working only in the low power embedded market. So that's what the current ongoing of RISC is. And I hope that all these startups eventually transition into the high performance market and they eventually start competing with the real big players like Nvidia and ARM and OpenAI. So they that's what I think the future of research startups in India is. They have to eventually adapt. They cannot get stuck in the same embedded low power domain. I talked to the Inco Semiconductor CEO recently uh, at IIT Madras, and he said that currently Incore is doing only for embedded low power markets. They still haven't penetrated the high performance market, and I think a lot of other companies are also there in the RISC-V symposium at IIT Madras. There was Ola Electric. There was a lot of other companies which emphasized and on the fact that RISC-V has to penetrate the high performance HPC market. That should be the aim in the next 5 to 10 years. And I believe uh, the startups in India they have the power to do this. And I believe in the next 5 to 10 years we will eventually be competing with the likes of Nvidia and other companies and other architectures. So that's what I believe the future should be.
Yeah. So is someone listening and want to start their own RISC-V hardware startup in India? So what should be their first step and how should do they go about it?
Yeah. Again, I'm not really an entrepreneur. I'm not really a startup founder, so I would not have much experience on this. But again, I would reiterate to my previous question, right? You have to know which market you want to target. So if you want to design a startup, you have because the VLSI or a hardware startup is really difficult compared to software startup, right? I mean, if you're a software company, you can design a software in a couple of weeks and say that, oh, I've designed the app. You can anyone can use it. Any market can use it. Okay, like, but that's not the case with hardware. Hardware is really difficult, and you have to be very specific which market you want to target. So if you want to design something which is in the embedded low power domain, or I want to design a chip which can do only which can use only very less power, or no, it's used for smartphones, not for data centers. So the main advice I would give for anyone starting a RISC-V or starting any hardware startup is recognize the market first. You have to understand the market first and what the customer wants from you. So once you get to know what customer really wants, what customer market is, then based on that market which you want to target, you can design a product. So that's the whole advice I would give to any startup. Right, first understand the market and what exactly the market is lacking, right, and which market has a lot of competition and which market can be disrupted. So if once you understand that in the hardware or VLSI space, you can build a project or the product based on that market, and you can eventually scale up that project and become a very successful product.
Yes. So, last question. So, if you could give a piece of advice to someone who wants to become an open source contributor, especially in RISC-V, so what would it be?
Again, my answer remains the same, right? Keep your eyes and ears open, exploration, curiosity. So these three things which you have to be very focused on, right? You should never let go of the curiosity in you to learn something new. And open
Yes.
source is just like anything else. You just have to know which domain you want to target, right? So once you build up the curiosity to learn something new, you'll eventually figure out what domain you want to contribute to. So an open source is really simple. You don't have to stress it out. Open source is really simple. You just have to go to GitHub, see what project is going on, see if you can help. Just message them saying that I want to contribute. I can make your design better. I have a lot of contributions to do, and so you can just get started. It's really a matter of just getting started. So once you get started, you will eventually figure it out. So my single advice for almost everyone to get started in open source is be curious, right? We always never stop learning. That is one thing which I always focus on. You should always never stop, always be updated with all the current trends, and always adapt to the current industry, and always keep learning. Never stop learning, right? Never ever stop learning. Always be curious, and RISC-V, I think it is a really big opportunity. And once you get started in RISC-V, there is no going back, and there is no there is nothing called, right. You won't feel that maybe RISC-V has no future. No, RISC-V really has a very big future, and I think it is a it will disrupt the market. So open source contributions is really about curiosity, and you can get started right now. I mean, I will share my email at the end of this podcast, and you can contact me. I also have a LinkedIn up, and if anyone wants any advice, when anyone wants any mentorship, you can contact me, and I'll be really glad to help all of you.
Yes. So, one last thing, that why open source? Why we need it?
Yes, so it's again a very good question, and I know the answer to this because almost everything you see around you, right? Let's say the laptop which you're watching it on, the headphones which you're listening to, the fan, the TV, anything, everything at an instant, at a moment, was open source. So each and every software do you see, right? Your laptops or your Bluetooth device, anything, at a moment it was open source. So almost every piece of software or hardware you see has come from a person somewhere, some PhD guy in some institute who open sourced code, and people took his code and made their own product. So open I the reason why open source is because all the thoughts, right, all the design and all the creative ideas They come only when the idea is open. Only when a lot of people are contributing. A lot of people are contributing to that idea. Then that's the only way the idea can go forward. So open source is a really a good way to craft your idea and to craft that project or whatever you want to design. So that's why open source is really important, because all the great ideas which we see, right, all the great ideas, all the great products which you see have come through open source. So open source is the way forward, uh, because that's where all the ideas and all the design implementations and all the ideas come through. So open source is a really way. And again, the biggest another important reason is communities, right? Open source community is really big. A lot of people there, and I always believe in the philosophy that two heads are better than one, right? So if you have a lot of people helping you on a problem, you'll eventually fix it at much shorter time than you just working on it. So if you say I have an issue with the I want to design a CPU and I want some help, so in a matter of seconds, you'll have multiple people coming to your help and coming to your mentorship. So again, we have to break the shackles of closed ecosystem, and I think a lot of people were also advocating for this, right? So you see Elon Musk also advocating that OpenAI has become closed AI now. So he's really against it. So again, open source is the way forward, and I think if I don't want to emphasize that open source, everyone has to do open source because it's up to them. But if you want to get started, if you want to get started on anything, on any product or any design, open source is the way forward, and you can really learn a lot if your ideas are open and there's no restrictions or there's no barriers between learning, right? So in those cases, open source is really important.
Yes. So let us start with the Q&A session. So anyone have questions? So those who are putting in the chat box can open their mic and speak. So would you like to talk about the challenges in REST-V verification?
Verification. Yes. So I'm not really a verification expert, I would say, but I think the challenges in RISC-V is we still do not have a comprehensive suite for testing all the instructions. So that is the most important thing. So when I worked in open hardware foundations, I realized when I wanted to verify quiet precision. So it's something for floating point. It's quiet precision basically. It's a floating point algorithm or a representation which has 128 bits. So currently, if you go to RISC-V repositories, they still do not have that implementation. They still don't have that high precision 128-bit floating point verification suite there. So the challenge I faced, I had to design it from scratch. I had to design an entire testing suite in Python and Verilog from scratch to support 128 bits of data. So that's the main issue, right? If you compare it to any other ARMS or x86 testing suites, they have a really fundamentally established testing suites which are compatible with all types of data, all types of memory, all types of configurations. So the main challenge in verification is we need to have a very comprehensive suite of uh, of testing all the instructions and testing all the different configurations of your design. So that is the main challenge. And once we overcome the challenge, it will be really easy for us.
Any
Shreesh,
questions?
Yeah,
Shreesh, this is Sandeepan. Since
okay,
you mentioned the challenges about REST-V verification and you have been working on with close collaboration with REST-V International. So, is REST-V International doing anything on working on REST-V suite for a verification of extensions? Let's say when we got atomic supervisors,
right, right,
debug and
yeah.
hypervisors.
Right. So RISC actually has a repository. You can check it out. It's called RISC-V tests and RISC-V architecture tests, right? Then actually the people behind this are Encore Semiconductor actually. I think the people at Encore actually are the one who designed these suits actually for RISC-V. So and I get a question, right? I get a question. So RISC-V, the verification suits is the problem in RISC-V currently is they are really lagging in verification. They did not put a lot of resources there. So let's say if let's say next week a new profile comes up, RVA 23 profile comes up, so they do not have the verification suite for it. So customers will be left waiting. So that is the main issue, and RISC-V is currently working on that. And I think RISC-V and Incore are the main contributors to the RISC-V verification suites. And I think folks at Incore Semiconductors and I think Lavanya from IIT Madras, she's a founder of Fioma Systems. So she's actually really into tackling this issue. They already have a testing suite for most of these profiles and verification suites, and they haven't open sourced it. That is up to them. That is their decision. And again, RISC-V really has to speed up on this, right? And they have to. And if you go look at the repository, right, it's really outdated. RISC-V architecture test is really outdated. So I talked to the maintainer. The maintainer actually from Incore Semiconductors. So I asked him why haven't they updated all the new extensions, and also and they haven't updated the new profiles and new configurations, new instructions. So they mentioned that he mentioned that we simply do not it's too hectic for us, and we simply do not find a way where we can contribute anything, because a lot of people currently are more focused on design than verification, which I believe it's wrong. For every design you do, you have to equally develop a very verification suite for it, so that you can uh, exhaustively verify that CPU. So verification is really important, and RISC-V is actually tackling that currently. And even people at Open Hardware, and I talked to David Harris, and he mentioned that he's working with a PhD advisor on it, and he's trying to develop a lot of extensions there. And it's an actively ongoing work there. A few folks from Sci-Fi, so Andrew Waterman, you might have heard of him. So Andrew Waterman is also working on it, and again, I know it's an issue there, and I hope they resolve it, and I hope they work on it quickly. So that's what I believe, and I hope they do it, because a lot of people focused more on design than verification, which I believe that's not the case, and that should not be the case. So I hope they come with it, and eventually we will find a way where we can contribute both towards design and verification.
All
Yes.
right, that answers my question. Thank you.
Thank you.
So, Spurti, you have some question?
Hi, hello everyone. Thank First of all, thank you Anushka for hosting such an amazing series, and thank you Shreesh for delivering such an inspiring journey. At the outset, I just wanted to know what are the career prospects or the portfolios that a particular person interested in Risk 5 can have in their career portfolio.
Like
Okay.
everything. Like you can,
So
if you
yeah,
physical design also, verification
yeah, you can go
everywhere.
ahead.
Yes.
Yeah, essentially what she said, right? RISC-V is an architecture. It's not entire different domain, just an architecture in that stack. So it's just like x86 and ARM. So you can do whatever you want with it. You can design software, you can design hardware. So it's up to you. So there's at least hundreds of opportunities there. You can do physical design, you can do verification, you can do design, you can do microarchitecture, you can do software, you can do hardware, you can do manufacturing. So there's so many things there, because RISC-V is not some niche skill. It's just a parallel implementation of which has already been done. So it's not really there's a plethora of opportunities there.
Yes.
Okay, got it. Thank you.
Any more questions? I think everyone are done with this. So if you have any queries, so she is a part of our community, RISC-V group. So if you have any doubts, you can always ask in the community. And you were going to give your email ID. So
Sure. Yeah. I'll just give my email ID, and if anyone has any questions, or anyone looking for any mentorship or any guidance, I'm always available. You can contact me on this email, and I would be really glad to help every one of you, because I believe RISC-V is the future, and we need all hands on it.
yeah, okay. Thank you so much. Thank you for joining, Sheesh.
Thank you.
Thank you so much.
Thank you. Thank you for inviting me.